Hi, everyone, and welcome to the MLOps Live webinar series. It's great to see so many of you with us today. My name is Sahar. I'm the VP of Marketing at Iguazio, which was recently acquired by McKinsey and is now a part of Quantum Black, McKinsey's AI arm. And I'm very pleased to welcome you to another session of MLOps Live, this is session number 24. We have a very special session planned for you today, but before I introduce our guest speaker, I just wanted to give you a couple of quick updates on how the webinar today will run. First of all, we're recording the session and we'll send it to you afterwards so that you can watch it at your convenience. We'll also hold a live Q&A towards the end of the session, so feel free to ask your questions and fill them in the Q&A panel at the bottom of your screen at any time throughout today. We'll be running 2 live polls. These polls help us make the sessions as valuable as possible for you. And we'd love to hear from you and your experience with MLOps. So please do fill those in. And we'll share the results with you at the end, as always. And we invite you to join the MLOps Live community to keep in touch after the session, ask our speakers additional questions that may come up afterwards, and just in general, keep in touch. We love to see you. We have 500 community members right now, and the community is growing all the time. We'll now put everyone on mute, and like I mentioned earlier, we are recording, so please feel free to look back at the session afterwards. And with that, I have the honor of presenting or introducing you today to Gennaro Frazzingaro, who is head of AI at Sense. They built an incredible automated AI chatbot, and Gennaro will be explaining a little bit about Sense, how the chatbot works, and the challenges that they faced, how they overcame it. He's going to give us a detailed kind of overview of the way that the team is built, how it's structured, what kind of tools they're using, and so on. I won't give any more spoilers than that. I will leave it to Gennaro to provide all the details in a second. We'll hold the quick poll, and then we'll hear from Yaron Haviv, co-founder and CTO at Iguazio, about best practices for building a Gen AI chatbot. We'll see a couple of short videos, and we'll continue to a poll. We'll then hold the live Q&A, and we'll be very happy to hear your questions and to address them at that point. With that, I will hand it over to Gennaro. Thank you so much for joining us today.
I'm sure most of you have, looked into scaling ML operations, what it takes. So these 3 challenges may sound quite obvious to you, but just to recap them, at least that's what was our experience, what our experience was. Number 1, you have multiple projects and experiments to manage, right? And you have to figure out what is the, how to deal with all these projects and versions at scale. Number 2, speed is important to you, both in terms of efficiency and speed to market, but it's not that easy, right? It's actually pretty hard. Number 3, you need a very sound deploying and monitoring strategy, which in most cases is hard to establish as a practice or expensive to implement. All of these challenges have one thing in common. Any solution requires different teams and disciplines in your organization to come together. At the very minimum, your data and analytics team, your DevOps, and your ML and data science teams will have to agree on the technology to use and on the interfaces to make the data flow through the different systems effectively. So what we did at Sense, we built a platform that looks like this. This is obviously very, very high level, but at the very top, we have heterogeneous data sources, all feeding into our data lake. We collaborated with the data and analytics team to centralize all of our different data pipelines into one Snowflake instance, which is now the central repository for any data needs at Sense. Then we onboarded Iguazio, which helped us fill the ML training and serving component of this pipeline. It also gives us many tools to integrate with other systems or satisfy other requirements. An example of that is Label Studio, which is a key component to speed out labeling and data annotation needs. In general, the faster the data flows through these different subsystems, the easier it is for you to achieve efficiency with any ML project, not just chatbots. But the best infrastructure is not enough, right? We knew we also needed good practices and a clearly defined process. Today, at the start of each project, we make sure that we religiously set these two goals. Number one, we set a very sound evaluation strategy to drive progress and discard unsuccessful experiments quickly. Number two, we never compromise on agility in making changes. Or, and we think like from the very beginning about reinforcement learning through feedback. Iguazio boosted the productivity of our ML engineers and data scientists. An example is like, the most common example is that any ML engineer or data scientist can train models on remote GPU and truly manage the full stack with very little or no involvement from DevOps. Through this platform and infrastructure, we're also constantly analyzing conversational data, which are like real conversations with chatbots. We usually do that in Jupyter notebooks, and we derive a lot of insights from that. An example is like, what are the incremental improvements we should deliver to the model? How to adapt to the language being used in the real world? And what kind of use cases we need to implement based on, what these concepts are showing. We often bring these insights also to our customers, which is something they love. So to summarize, the right data and ML pipeline is key to streamline operations. But a sound process around training, evaluation, and experimentation is the other key ingredient to make machine learning projects successful, at least in our experience, and drive tangible business value. Now, I wanted to take a moment, and turn back to Iguazio. We evaluated a lot of alternatives before choosing Iguazio. Because of our requirements and constraints at the time, we were looking for an all-in-one solution that could help us iterate fast, narrowing the scope of what people new to MLOps had to ramp up on. So we went ahead and installed Iguazio on our AWS cluster. That was, fairly easy. One thing to note is that monitoring cost and adjusting resource allocation for your projects is extremely important, especially if you don't want to get any surprise on your AWS bill at the end of the month. And currently, we found the perfect balance by using GPU-bound instances to speed up the training pipeline in our staging environments, but less GPU memory for the serving pipeline in production environment. Our chatbot backend proxies to Iguazio, which serves the model in production on every single user message sent to the bot. And our P99 in Iguazio is below 100 milliseconds in production at peak, which is quite impressive. You may also know that Iguazio uses Kubernetes, which helps a lot with auto-scaling based on traffic. So all in all, I would truly recommend Iguazio for the following reasons. Number one, once data scientists or machine learning master the technology, they start having kind of superpowers, because ML Run gives any devs or scientists a way to manage the full stack using Python. They can use Python to schedule how they want to run their jobs, right? And what I really like about it is that infrastructure is fully managed as code, and it's managed in GitHub. So it goes through code review and all of the goodness that comes from having infrastructure as code. Number two is monitoring out of the box, which covers the basis. You can also easily build dashboards on top of the standard ones, and that's very easy. And number three, and perhaps more importantly, Iguazio's support since the start has been phenomenal. They've been true partners of ours and in every step of the way. As I mentioned earlier, ChatBot isn't the only product we're using Iguazio for. Along with closed source models like OpenAI and Anthropic, we heavily use Iguazio for a variety of different projects. For instance, we constantly fine-tune open source LLMs, or religiously experiment various deep learning techniques to make our products better. Our ability to match candidates to jobs, for instance, or jobs to candidates effectively, is gonna be our next breakthrough, I believe. But I'm also very excited about a product called Sense Copilot, which helps recruiters work more efficiently, predicting what they should be doing next in the platform. But more in general, we think about AI holistically from both a candidate and a recruiter point of view, which is what drives us every day. Ultimately, we're excited to lead the charge in shaping the use of AI in recruiting. And so that's quite exciting. I'm excited about the future. So thank you. Thank you, everyone.
Thank you so much, Gennaro. And clients like Sense are the reason that we get up in the morning. We really, really appreciate the kind words. And it's incredibly innovative. I mean, this use case is very difficult to build out. And the amount of details and the amount of thought that's put into it is really inspiring. I see a lot of folks in the chat, and we see this all the time. People that are trying to build similar applications and are coming into a lot of challenges, a lot of them very similar to the ones that you've described. And hopefully this session today will be helpful for other folks who are building out their AI chatbot. So thank you so much for all the insights. We're going to pause here quickly to take a quick poll and to hear from you. So I will launch our first poll question momentarily. All right, now you should be able to see the poll. And the first question we want to ask you is, how are your data science and data engineering practices aligned today? And now I'll hand it over to Yaron Haviv. Yaron, you are welcome to join the stage. And if you would like the slides, just email us, info@iguazio, and we'll share a version of the slides as well. So while Yaron is joining, Gennaro, I'll just ask you maybe a couple questions and we'll get the ball rolling. Can you share a little bit about how the team works and how the team is structured at Sense?
So as I was mentioning earlier, I think it's important that regardless of how the organization is structured, there is, in any ML project, different disciplines that come together, right? So at Sense, what we have is a data team and an analytics team. They work obviously very, very close to each other, and the data team is responsible for all of the different data pipelines that go from our customer data sets into our platform, and from our platform into the back to the customer's data. And the analytics team is basically responsible, as you can imagine, to build on top of these data pipelines to derive insights, to aggregate data in a meaningful way, and do business intelligence pretty much. We work with them on a daily basis. My team, as I mentioned, is ML engineers, data scientists, but we also look after a lot of different products. So we have backend and frontend engineers, and we have one common interface, being Snowflake, where all of the data, really every data that we deal with at Sense, eventually gets pushed to, and that's our contract, right? So anyone at Sense that really needs to access any kind of data, they will go into Snowflake and access that data. Through Snowflake, we basically, on top of Snowflake, we use Sigma for dashboarding. So that's where we derive a lot of insights for not just machine learning, for other different purposes. And then Iguazio connects directly to Snowflake, so we can pull data from Snowflake into Iguazio when needed. Most of the times we use Jupyter notebooks to analyze that data, and as I mentioned earlier, derive reinforce our models or come up with new use cases or solutions for the problems we have based on the data that we have access to.
I'm sure that makes it a lot more efficient and kind of easier for the teams to have that connection directly.
Yeah, and there isn't necessarily an answer fits all, right? The one solution fits all, and depending on your tech stack and depending on how your organization is structured, there is many different things that can work. But I think collaboration is extremely important.
100%. And I think we might have Yaron on the line now. Yaron, can you hear us?
Yes, unfortunately, my PC died in the middle.
Oh no.
First time it happens in the middle of the webinar, so I'm from my phone, but you can advance the slides, and in the meantime, I'm restarting my PC. So,
Great. Hope you'll be back up and running in a second. Fantastic.
So thanks very much for the presentation from Sense. They're a great client of ours and doing some remarkable work. What we want to focus now is essentially how to build a similar solution using LLMs and generative AI. You can use the different approaches, and over time we see even Sense is trying to adopt LLM for certain areas, and there are different approaches that I'll describe in a minute. But anyway, when you build this kind of application with for generative AI, you have four main components in the application. The first one is obviously the data processing. So when you are getting the bot to respond, whether it's for some questions or based on some documents that you created, or based on any other knowledge, you need to prepare the data and sometimes index it in a vector database, or sometimes prepare it for further tuning or training of the model. So that's the first part in any solution, is the data pipeline. And the next part is the machine learning pipeline, which is essentially around testing and building the model. If you're tuning a model, then you need to take a baseline model, take some custom data, build a new derived model, fine-tuned model from that, and then evaluate and test. Sometimes you may skip building or tuning a model, but you still need the evaluate and test phase to essentially verify your prompt or verify your model is actually behaving according to the plan. Some of the challenges around the new LLM models that they can easily hallucinate or generate some fake data or some toxic data and so on. So we want to make sure that whatever we're building, we don't want to find it out in production. We want to see and test it as we develop the application and before we drive it into production. The next element below is the application stack or the application pipeline. This is where you actually manage the state of the bot. You get an interceptor request, you parse the request, you may contextualize the request with some user information, with historical information about this specific chat session or chat, build a prompt, score the prompt with an LLM, and then do some processing, whether it's filtering, formatting, and so on. And the last element of the application is the monitoring. It's very important to be able to know that the model is actually behaving according to expectations. There's no bias, there's no hallucination, answers make sense, there's no accuracy problems or drift, and so on. So we need a mechanism that collects all the information from the application, the questions, the answers, the metadata, the confidence level of the model, etc., writes it into some structured format, and then essentially going for that data and building dashboards and so on. But also that data from production can be reused for further fine-tuning or testing of the model. So we can take that data and see which answers weren't correct or with very low confidence level, etc., or got some score from the user that user is asking again and again, no, something else, or no, I didn't mean that, no, can you repeat? That could be an indication that the answer is problematic, and we can label that and send it to human labeling, and based on that build refinement or reinforced learning loop where we can go and fix the problem. So this is the four elements of the pipeline. So what we see here is a typical example of how to build a conversational bot. So it consists of several elements. I'm going to dive into each one of them. So we have here several elements in the architecture. The first thing is intercepting the question. So you get the question, I want to reserve a hotel room, for example. And we need to understand that question and understand what are you really trying to do. Maybe you're asking a question that I need to pull from a static document. Maybe you're asking a structured question where I need to go to a database, look up the result. For example, what is the balance of my account? or maybe you want to apply an action, turn on the light. So first thing we need to do is identify the intent of the user. The only challenge is the intent of the user may be actually derived from a set of questions, like I want to reserve a restaurant. Tomorrow 8 a.m. would be, or tomorrow 8 p.m., that will be 2 sentences. So how do I know that tomorrow 8 p.m. is a restaurant reservation? I have to essentially go and look back into the previous questions. And this is where I need to do something called refinement, is take the historical information of all the different questions, take the last question and build a new question, a new text that is trying to encompass all that information into one thing. This is essentially, if you look into the previous technologies, like Dialogflow, Reza, etc., what they manage is essentially a state machine. You ask a question, you go into a state. I want to reserve a restaurant. Okay, you go to a state of restaurant reservation. So if you happen to go and say, I want to reserve a restaurant, and then in the middle of the sentence, you're saying, I want to book a ticket, then, the machine may actually get confused or not know what to do, or maybe it didn't know how to classify correctly your statements. And again, there are many challenges with building bots on state machines. And by leveraging this concept of taking historical information, rebuilding the question, it's easier to classify. Once we understand what the user really wanted to do, then we essentially need to go to the specific application. Think about it as a website. You have different clicks on the website. You go to about, marketing, products, etc. So think of the chat as a similar application where you essentially need to know what was the intent. Based on that, go to a sub-application. A wise move could actually be to create microservices or models for each one of the sub-applications. So then think about like creating a new rolling upgrade of the question and answering application, or the structured question and answering, or introducing a new tool, a new application could be easier if we create each one of those components as a microservice, something that we just load and so on. So if we go specifically to a scenario of a question and answering, just like a ChatGPT, I'm asking question about the document or about, what are the different credit plans you have. So I need to take the question and extract information, meaningful information from the question. For example, what are the different credit plans? So credit is a category that I want to extract and use that to find specific documents about credit. So this is where we need to have what is referred to as extract entities or slots with our element in the sentence that will be applicable, like, or what are the different plans for next year. So I need to go to next year. I need to know that next year is an element and search within the database about next year plans and so on. So the next thing we will do is find the document using vector databases and search. And then we get an answer. We take the answer and we use an LLM to structure the answer as a nice thing we want to say. Thank you. Hi, Joe. These are the different plans and so on. And then as we respond, before we go and send a response to the user, we have some extra work to do. First, we want to validate that this is not hallucinating, that this is sort of legit question, answer. It makes sense. There are no, some garbage symbols in it and so on. The next thing, we want to format it, maybe HTML, or maybe, if we want to references, we want to put bullets and so on. So there's some text formatting elements, or if we're in WhatsApp or other tools, there may be some additional annotations. And we want to also save the state of the conversation. We want to go back and save that information to a database, update the user context, update the session context with what kind of questions were answered and so on. So the next question that will arrive, we'll be able to answer it. So that's a general architecture. Again, we can build as many tools as we want underneath. The next one is an example of a structured question. Like you're asking a question, what's my account balance? What's my account balance translates to a select statement of, let's go to the balance, let's filter by user ID of, let's say, checking accounts, run a query into the database, get a numeric response, and then use the LLM to structure the response in a natural text. Your account balance is, $2,000 or more, depending on your account. So that's in general the idea around that. Next slide. So, there are a bunch of challenges we need to address. We talked about some of them: hallucinations, toxicity, and so on, and also some other risks. You can see here different examples of that. Next slide. One of the things that we've done with MLRun was to essentially automate some of those flows. So we saw that we have different pipelines, batch pipelines for ingesting the data and for tuning and training the model or testing the model. And we have some real-time pipeline. So the first thing we've done is use the MLRun batch pipelines to do the data processing as well as the testing and validation of the different models. And we use a CI/CD based flow workflow and supports, GitHub or Jenkins and so on. So you can push code and that will trigger a workflow that will run the different steps and build the new model or verify the new model and the different components of your stack or index the data and so on. So that's done using MLRun. The nice thing about MLRun, it can also work with elastic resources, GPUs and CPUs. So if you're doing tuning of a model and that requires GPUs, MLRun would allocate them, create the Kubernetes job, run them, decommission the resource. So you won't spend a lot of money on it. The other interesting thing that MLRun Marketplace, which you can see the picture on the left, we now have about 10 functions that are specific to generative AI, serving open source models, tuning, transcription, and so on. And we have a large team now in McKinsey that's working on additional components that people can just go and build pipelines for different use cases. Next. Yeah, so this is another nice thing about MLRun is the ability to compose real-time pipelines. So this is an example of an application pipeline where we're getting some requests. We need to do pre-processing, then serve an LLM. In this case, we're using an open source LLM, do some post-processing, for example, formatting, verify no hallucination, all those different things. In this application, we also put a Hugging Face model for toxic filter detection and respond to the user. Building all that complex application pipeline requires very small amount of code. What you see here is I'm composing a pipeline with built-in components in some cases, and I could go and test it in my notebook or my dev environment. And when I feel it's ready, I just push deploy. Deploy actually generates the microservices, map them to Nucleo functions, build auto scaling groups, and all the different resources underneath API gateways, all of that. So you don't need to think about any engineering effort. You just build your code, push deploy, and you have everything running production worthy. You can deploy it on different clusters, staging, production, and so on. Next. I won't do the full demo, but I'll show you those two repos. So we're working on several recipes. We have now 3 recipes. One is the LLM bot, which is more of an interactive bot using OpenAI. We have the LLM tuning, which is an interactive bot that's doing fine tuning based on open source models. We have another call center demo, which is doing a video and audio analytics for calls, and based on using open source models and classifying them. A pretty cool thing. So let me share my screen for a second. Sorry. Okay, I still have a problem with my PC. But anyway, maybe we could take it offline. You have the 2 links. You could go over the 2 links. In each one of those Git repos, there is a tutorial, and you could see how they're structured. We are working to further improve what we call the LLM bot demo, which and include all the different components that, Sarah, can you show the slide with the Git repos?
Yes, absolutely. We'll also share them in the chat in a minute.
Okay, let me. Yeah, so you can go over those and see essentially you have these are actually, if you're using MLRun on Kubernetes or on Iguazio, either the open source or the commercial version, then you can just git clone or do load project of that Git repo and just run it, and you have everything. And then if you need to customize it to your own data in the data pipeline, there are things like scrapers. So you can just, instead of reading, for example, using the MLRun documentation site, building QA on top of it, instead you can just point it to your website and your web pages and build a Q&A bot with your web pages. So things are pretty modular in the demo, and you could just leverage that, build it, and build your own solution based on those examples.
Fantastic. Thank you so much, Yaron. And we'll copy the links into the chat in a minute, so you'll all have access to those. We'll just pause quickly for another quick poll before we jump forward. And this one is about your biggest challenges with NLP. So I will launch that now. Okay, and please do let us know what you find is the biggest challenge. Thank you very much. And now we come to the fun parts, the Q&A. There's a couple of great questions already in the chat. So Gennaro, if you, yes, there you are.
Hello.
All right. So the first question here, I think, is for you, Gennaro. What is the easiest way to deploy an AI bot? Michael tried Heroku, but it crashed immediately after deploying. What would you recommend?
Yeah, I mean, I don't know about the specifics of what didn't work in Heroku. I think it really depends on what you're trying to do. And Yaron was also explaining, like, general purpose architecture to do, to implement like an AI bot using Gen AI, which I think it can be extremely powerful. I'm curious if the question is about, like, the operability aspect of it, or whether, like, what kind of like architecture, you should be looking into. Would it be possible to clarify the question so I can give a better answer?
That's a great question. Michael, if you can hear us, feel free to add an additional question in the panel and we'll be a bit more specific, but I think that's great. In the meantime, let's move on to a question for Yaron. Is MLRun free for enterprise use since it is open source? Can you say a bit about the open source version, the enterprise version, the differences?
Yeah, so MLRun is entirely free, entirely open source. We have several flavors of MLRun. There's a mini MLRun for Docker with a small installer, but it doesn't incorporate like elasticity, GPUs, and so on. There's a version for Kubernetes, which is like fully fledged. What Iguazio provides as a managed service also incorporates like a single sign-on security, sort of a managed experience. Also managing the other resources that are connected to MLRun, the Prometheus, the Grafana, the Jupyter, and all of that as a managed service experience. So we essentially have users using different flavors. We're not against any of them. It's not really an intention to make money off of it. It's more like when you get something that's commercialized and you need support, then we need to recoup some of the investment.
Thank you, Yaron. Another question is about search queries, how to deal with search queries. Clement has a news website and he wants to build on top of it a chatbot that can summarize news articles in a chronological way. Question for either of you, what would you recommend?
Yeah, maybe I can chime in. Again, there is a very common pattern, and you could see that in the two demos. Again, we are improving them to incorporate a lot more intelligence. Part of the challenge that we've done also in the tuning demo of the MLRun documentation is that the naive way that you'll get everyone and all the demos in Medium would be to take the document as is and index it. The problem you may not get the best results. So sometimes the documents have a certain structure. There's like a header and a body. There's all sorts of tables sometimes, etc. So you do need to do some data preparation and potentially leverage the extra information. Like if you have a section in a document that highlights some information, you may want to use it as as a label or as the question, and then the paragraph within that section would be the answer. This way, the LLM will know that this section is the relevant section. If you just use associations, meaning vector search, it may pick up just based on seeing a familiar word, will pick up that section and answer. So if you really want to avoid hallucinations, you need to do more data processing and structuring, also keyword searches. We can take it offline, but there are a bunch of things that we are going to put into the next versions of those demos.
And Clement is adding a bit more information. The problem is with the dynamic information that is being updated regularly.
So what we, again, just like in data lakes and feature stores, what you need to do is version the data. Again, the thing that we're seeing over and over, and I'm visiting a lot of clients and seeing what they're doing. People are so hurry and a rush to build a demo that they forget engineering practices. You need to version data. Documents go and update. So if you version the data, when you're querying, when you do the bot, you have to refer to which version of the data you're actually going to use in the index search. So there are a bunch of practices you need to apply, like within rolling upgrades and versioning data and all of that, referring to the right data version, using labels and keyword searches to do filtering based on metadata and so on.
Thanks,
Yeah.
Johan.
I just wanted to double down on what Johan said. The structure, like understanding the structure of the document, is extremely important. Because in some cases, doing a full document search, like not doing chunking, like just using vector databases to retrieve the full document, is preferable. We have a lot of sense where we may need to retrieve like candidate to job description pairs, and that is the most efficient way. But in many other cases, there is sections of the document that are more relevant to you. And the more precise you are on what you're giving the LLM to construct the answer for you, the better the answer is going to be, and the lower the chance you're going to do you're going to lead the model to hallucinate. So different techniques. But for news, I think that's a very interesting use case. And if the data changes frequently, just make sure that the metadata, as Johan said, has a version information about the data you're trying to summarize.
That's great advice, and it's actually a really good segue into the next question. So we talked a lot about documents, but what happens when you have videos? So Boyd has an organization with over 20 hours of various videos on healthcare. And he's asking if there is a way to create a chatbot that detects the end user's sentiments and provides a summary of information, directs them to the best location in the videos, and so on. What do you guys think about
So
that?
we actually have a project in McKinsey that does similar things for like satellite footage. You get like satellite footage, and there's an LLM, or so not a Gen AI model, not an LLM, a video model, or an image model that analyze the content of the images, and based on that generate a question and answering system. So that would be something similar. I wouldn't advise to just every query go and examine all the pictures. I think one thing you could do is essentially just like we're doing on the call center demo. In the call center demo, we take the audio, we generate as many features as we can from the audio stream. We take the text, we start asking questions about the call. Was it what's the sentiment of the call? Was the issue resolved? Was the and all sorts of questions. We generate a table of metadata based on that information. So you could do the same for an image. Say, which object do I have? Maybe identify how many people in the person or whatever. Structure everything into a database, and then you could just look up that information and then format it into text.
I obviously agree. Like, doing text classification is the easiest, right? So that's where I would start. And yeah, there's other features that you can build if the video is relevant for whatever reason. And yeah, keep going down that.
The more the format advances, the more kind of difficulties and challenges there are, for sure. Another question here is about privacy and security issues of using open source components. Yaron, can you chime in on that?
So actually, some people say it's actually more secure and more private, because if you think about OpenAI, they're essentially trained on GitHub and Wikipedia and so on, and you may have seen some of the lawsuits around data privacy on that. So the commercial models are trained on the same data. Actually, there are some concerns around how much they're using your data when you're starting to prompt and so on. Legally you can opt out, etc., but there are still a bunch of concerns around it. There are examples in the internet. You could see that you may get private data as answers to chat, with phone numbers and so on. So I don't think the commercial solutions are safer. I assume they put a lot more emphasis on doing that. But if you are tuning your own model, for example, you build a question and answering system, and you tune your own model, you control in a much better way what's the data going in. So if you make sure that the data pipelines filters out privacy, then it will not emit any private data. This is actually part of our call center demo. There is a component of PII filtering. It's pretty cool. It's actually using some Hugging Face model for entity detection, and it knows how to filter out all the different private data patterns, names, social security number, credit cards, etc. So then when you're tuning the model or prompting the model, the data will not appear in the result. So there are solutions around it. Again, you can contact us for more details on that.
Yeah, I actually wanted to chime in too, because I love the question. I'm a privacy enthusiast. So a lot of the, every time we dive into a specific problem statement and looking for solutions, closed source models are usually like the way to bootstrap things, like using OpenAI, Anthropic. But they always bear the question: what's going to happen to PII? What's going to how can we just rely on these systems to pass I don't know, candidate resumes or candidate personal information? They're not necessarily social security numbers, but you can have phone numbers, email addresses, and things like that you don't really want to relinquish control of. So many times the trade-offs come down to how much an open source model can give me. And so in parallel, we usually start other experiments of fine-tuning open source models in Iguazio to see, to compare, what a closed source LLM can do versus an open source LLM can do for that specific use case. And yes, as Yaron said, by owning the whole data life cycle and including the model, you have much more control over your data. So if privacy and security is extremely important to you, there are techniques, right, to use closed sources of LLMs to and still comply with your privacy requirements. But yeah, the open source approach is definitely this is one of the biggest benefits of using open source. But yeah, I'm happy to take more questions offline around this. I have a lot of thoughts to share.
That's fantastic. And I think, it's absolutely critical for organizations. Many are concerned about this. So it's a really interesting question. Thank you.
I can take the question around enrichment. Enrichment means that you get a question from a client, and then you need to add the data. The two data elements you want to add. One is who's the user, and the second is the historical session information, like what were the previous questions of that user. If you know who's the user, you could do some pretty cool tricks like personalizing the request. If the user is a child or user is an adult or a man or a woman or has some buying preferences, you can in the prompt, you could say, I'm a woman in my 40s, like purses and so on. I'm not trying to be biased here. And it will generate the right answer based on your persona, or a more refined answer based on your persona. So the enrichment could be about the user context and about the previous question you were asking.
And there's another question here about intent. So you were speaking earlier about determining the intent of the user. And there's a question here of whether that is a classification problem or another type. Can either of you say anything about that?
Yeah, intent recognition is one of the branches of classifications. So yeah, it can be it is a classification problem at the end. There is many I mean. NLP has a very, very long history, right? So there's a lot of different literature on what is the best and most efficient classification technique to recognize user intent from a sentence. The literature usually starts from you have an NER component, an entity recognition component, which feeds signals into a bigger classifier, which then classifies the whole sentence based on entity signals and other signals in the sentence. But yeah, the short answer is yes, it is a classification problem.
Yeah, maybe to add to that, what we've seen with the LLMs is that it simplifies the classification process. With traditional classification, you need to classify, you need to essentially give a lot of different examples to the model of what classifies A or B or C. Because the LLM understands nuances, then it's easier to classify. For example, if I want to classify between booking a ticket and booking a restaurant, and I say, I tell the LLM, is that booking a ticket or a restaurant? It will pick up things like, I want to book a table. Book a table, obviously it's a restaurant. It understands the nuances, even though there's no restaurant in the statement. So these are just examples of why LLMs could be nice for classification. Again, there's a trade-off. If you use a very big LLM, it's becoming expensive to serve and so on. So you need to find the right balance in here.
Absolutely. And we're coming to the end of our Q&A. We'll just take one last question and then we'll start to wrap up. While getting the related context to feed the prompt by similarity search, what would you suggest, like extracting text, and also while indexing what you suggest? I hope that makes sense. The question about context.
Can you repeat the question? Sorry, one more time.
Yeah, I'll just read it out. While getting the related context to feed the prompt by similarity search, what would you suggest, like extracting text, and also while indexing? What would you
I think it's a good question, and it relates to something that we touched upon earlier. Usually those things you'll see in Medium and so on, what you do, you go to the vector search, you gather about 3 to 5 different chunks from the vector search, and you feed them into the LLM for summarization and sort of making it respond nicely. Now, what happens if you missed and you haven't really selected the right 3 or right 5 chunks, which can really be easy if you have lots of document, and then that's a problem. So what you probably want to do is things that we discussed before, is try and extract information from the question to refine the search, and in the indexing also apply keywords. Let's assume we have financial reports about every company about every year. Okay, Uber 2021, Uber 2022, and so on. So if in the question someone is asking how are the financials of Uber in 2022, okay, you can actually extract 2022 and Uber from the question and use it as a keyword search to filter down just the Uber financial document this way, because there may be another document that somehow talks about, Lyft says, yeah, compared to the competition Uber, this was the situation. The vector search may actually catch that, or maybe Uber 2023 refers to a previous year. The vector search will pick that one up, and you won't get the most relevant details for the summarization. So refinement using keyword and understanding of the text could actually really help in the accuracy.
Great. And now we'd like to invite you, if you enjoyed the session, to visit our website. It's iguazio.com/MLOps. You can find previous versions or previous sessions of the MLOps Live webinar series where we spoke about different topics, talked to different folks in the industry. Each one has a completely separate kind of focus. And we also invite you to read our MLOps blogs. We go very in-depth into lots of different topics having to do with MLOps, with scaling AI, with implementing AI, Gen AI, and so on. So we invite you to visit our website and check out all the different resources available for you there. I also want to invite you once again to join our Slack community. If we haven't shared the link yet, we'll do that right now. So you'll be able to join our community and continue the conversation, ask us more questions as they come to you, share your experience. We'd really love to hear from you and keep in touch. And at this point, I really want to thank Gennaro and Yaron for a fantastic session. Thank you so much for sharing your insights with us, for answering our questions, and for being here with us today. And thanks everyone for participating. We really enjoyed it, and we hope you did as well.